Welcome to the next session, my dear friends. In the previous session, we have discussed up to the question number 35 of the previous GATE questions from treatment of water. Now we are continuing in that series. We are continuing the next question, that is question number 36. It is GATE 2013 1 mark question. GATE 13 1 mark question. So question number 36. Question number 36. A water treatment plant having a discharge of 1 meter cube per second has 14 filters to treat the water. Each filter is having an area of 50 meter square, but due to backwashing activity, 2 filters are non-operational. Calculate the hydraulic loading rate in meter cube per day per meter square. This is the question. Okay. So what is the given data? So here the water treatment plant having a discharge is nothing but rate of flow. So rate of flow, that is equal to Q 1 meter cube per second. Okay, this is the rate of flow given, and having number of filters. How many number of filters are there? Number of filters 14. Okay, number of filters are 14. So each filter is having a surface area of each filter is 50 meter square. Surface area of each filter is 50 meter square, and number of filters work at a time. That means number of filter for backwashing, they are keeping 2 for backwashing. So number of filters works at a time, that is 12. Okay, so because 2 are kept for backwashing, so number of effective filters are 12 at a time. Okay, calculate hydraulic loading rate. Is asking hydraulic loading rate in meter cube per meter square per day. Okay, this is what he is asking. So if you want this in meter cube per meter square per day, so here the meter cube is here. Okay, so Q, we need to take Q in the numerator. So meter cube per second by this meter square is nothing but total surface area. He is asking hydraulic loading rate is nothing but rate of filtration. Okay, he is asking rate of filtration. So rate of filtration is nothing but rate of flow by total surface area. So rate of flow by total surface area in meter square. So this is nothing but hydraulic loading rate or rate of filtration. So or rate of filtration. Now what is the Q value here? 1 meter cube per second. And what is the total surface area? Total surface area, 12 filters are working at a time. So we need to take 12 into 50 meter square. Here the second I need to convert this into day. Then this will become, so 1 by 24 into 60 square day. That means 24 into 60 square meter cube per day. If it is 1 cubic meter per second, then for a day these many cubic meters will come by 12 into 50 meter square. If we solve this, we will get the answer. If we solve this, we will get the answer as $350 36. Yeah, 144 meter cube per day per meter square. 144 2 is 24, 60 into 60, 5 12 5 is 60, 12 2s are 24, 6 2s are 12, 12 into 12, 144 meter cube. So this is the rate of filtration for this filter. Okay, let us go to the next question. Question number 37. Question number 37, GATE 2015, 2 marks. GATE 2015, 2 marks, set 2. Question number 37. Now, a water treatment plant of capacity 1 meter cube per second has filter boxes of dimensions 6 meter by 10 meter. Loading rate to the filter is 120 meter cube per day per meter square. When 2 of the filters are out of service for backwashing, the loading rate is. Similar kind of question only. So let us take the data. The rate of flow, Q is equal to 1 meter cube per second. Okay, 1 meter cube per second. And the filter box dimensions, or we can call it as surface area of each filter. Surface area of each filter is equal to 6 meter by 10 meter, that is 60 meter square. 6 meter by 10 meter, that is equal to how much? 60 meter square. Okay, and loading rate up to the filters, loading rate was given. Loading rate, or we can call it as rate of filtration. So rate of filtration is given, that is equal to 120 meter cube per day, 120 meter cube per day per meter square. So this is the loading rate given. Okay, when 2 of the filters are out of service. So here number of filters were not given, but 2 filters are out of service. Number of filters out of service is 2. Then what is the loading rate? Here first we need to find what is the total surface area needed. Okay, generally here what he is saying is, this is the rate of filtration. Okay, and each filter box is having a dimension of 60 meter square. Okay, each filter is having a dimension of 60 meter square. Then what is the loading rate? See, generally for getting the loading rate, what is the loading rate? See, 120 meter cube per day per meter square is the loading rate when all the filter boxes are working. If 2 filter boxes are kept in service, out of service, then what should be the revised loading rate? First of all, let us find how many filters are required. Okay, first, number of filters required, total surface area. We have to find total surface area needed at 120 meter cube per day per meter square rate of filtration. What is the total surface area needed at a rate of filtration of this is equal to 1 that is equal to Q by RYF. RYF1, I will take it as RYF1. So it is in meter cube per day per meter square, and this is meter cube per day. Then I will get a meter square, that is the with a rate of filtration 1, with rate of filtration 1, okay, with rate of filtration 1. Now per day per meter square, this is rate of filtration 1, that is equal to total surface area is equal to Q, how much? 1 meter cube per second, by rate of filtration is 120 meter cube per day per second per meter square. So now I need to convert this second into day, then it will become 24 into 60 square meter cube per day by 120 meter cube per day per meter square. So this meter cube day will get cancelled. So this is 60 into 60. Okay. So 720 meter square is the area needed. 720 meter square is the area needed. So each filter is having 60 meter square dimension surface area. So number of filters. So this is total surface area. So number of filters needed. Number of filters needed, N is equal to 720 by 60. Okay, 720 by 60. So 12 filters are needed. 12 numbers are needed. But in this 2 are in breakdown. So number of working filters. Okay, number of working filters is 10 only. Number of working filters, if it is 10, then working area is 600. Okay, working area, working surface area is 600 meter square only. So 10 filters, each filter is having 60 meter square, then the working surface area is 600. So RYF2, now the rate of filtration RYF2 with 10 filters, is equal to, what is the amount of water needed? 24 into 60 meter cube per day is the water needed, with a surface area of 600 we are having. Okay, 600 we are having. So it is equal to 6 into 2.4. So it is equal to 24, 2 3s are 5s. Earlier how much it is? It is 120. If I convert this into seconds, earlier 120 meter cube per day per meter square, now it should increase. It should increase. 120. So what is the answer? Let us see. Okay, 24 into 60 square, right? Here it is 24 into 60 square meter cube per day. 60 into 60. So 12. So if you do this, then you will get it as 144 again. We will get it as 144. 3600 into 24 by 60 into 10, that is 600. Okay, I did some calculation mistakes. So 60 tens are 60, 600. So this 10 and this 0 will go away. So 24 6 are, it is nothing but 144. Okay, 144 meter cube per day per meter square. So this is the answer, 144 meter cube per day per meter square. Am I clear? So let me explain once again. Let me explain this question, a little tricky question. See here, the rate of flow needed to supply to a community is 1 meter cube per second. So a community needs 1 meter cube water for every second. Okay, and to supply this much, we are having filter boxes. So each filter box is having a dimension like this. So each filter box area we get from this. Okay, and the loading rate, the initial loading rate before sending the filters into service. Okay, this is the loading rate or rate of filtration, ROF1. Okay, this is the initial rate of filtration is 120 meter cube per day per meter square. If I put 2 filters in this total number of filters, if I put 2 filters under service, then the loading rate will increases on the rest of the filters. Then the loading rate will increase on the rest of the filters. Then what is the revised loading rate on the rest of the filters because of a breakdown of 2 filters? That is the question. That is the question. So for doing that, first we need to know how many filters are working with this rate of filtration. To get that, how many number of filters, so we need to find the total surface area. So total surface area needed at this filtration rate is how many? 720 meter square is the total surface area needed with this rate of filtration. So this is the total surface area. So number of filters which are working already, existing number of filters with this rate of filtration is 720 by 60, that is 12 numbers are present. In this 12 number, only 2 are under breakdown and number of working filters are now 10. So working surface area will become 10 into 60, each is 60 meter square, so it is 600 meter square. Now rate of filtration or loading rate with 10 filters. Okay, now earlier the loading rate is for 12 filters. This is for 12 filters, then if it is 10 filter, obviously this should increase. Okay, so that means rate of filtration is nothing but Q by surface area. So if you are getting surface area from rate of filtration, if you want rate of filtration, surface area will go as a denominator. So this is total surface area, 24 into 60 square by 600. So 60 tens, 10 6 are. So 6 into 24 is nothing but simply 144. 6 into 24 is nothing but simply 144. Okay, that is the solution. This is question number 37. Let us go to the question number 38. Question number 38. It is GATE 2018. 2 marks. GATE 2018 2 marks. Set 2 again. Question number 38, 2018. Okay, so let us read out the question first. So, a rapid sand filter composing a number of filter beds is required to produce 99 mld of a potable water. Consider water loss during backwashing as 5%. Rate of filtration is 6 meter per hour and length to width ratio of the filter bed is 1.35. The width of each filter bed is kept equal to 5.2 meter. One additional filter bed is provided to take care of breakdown, repair and maintenance. The total number of filter beds required will be. Okay, let us extract the data first. So what is the given data? Given data, a rapid sand filter has to produce an water of, so rate of flow needed, rate of flow or discharge, whatever it may be, okay, or discharge needed is equal to 99 mld, 99 mld, okay. Consider water loss during backwashing as 5%, okay. A loss of water due to backwash is 5%, okay, is 5%, and rate of filtration is 6 meter per hour. Rate of filtration is 6 meter per hour and length to width ratio of the bed, length to width ratio is 1.35 and width is kept as 5.2 meter. So width is kept as 5.2 meter. So number of filters for breakdown, filters for breakdown is equal to 1. So one filter we will keep for breakdown. So number of filter beds needed. Okay. See here, first thing, number of filters. For getting the number of filters he is asking. So number of filters is equal to total surface area by each filter surface area. Then we will get the number of filters. So we will get the total surface area from Q by rate of filtration. Q by rate of filtration. So the rate of filtration was given. Here if you look at the Q, this Q is a combination of potable water, and backwash water. Because whatever the water we are generating from the filter, in that some amount you will take it back for backwashing. So if you want 99 mld, here you want 99 mld, okay. So for backwashing we want 5% of 99 mld. For backwashing we want 5% of 99 mld. Okay, so total water how much we need to produce? We need to produce 99 plus. So we need to produce 99 plus 5 into 5 by 100 into 99. This much we need to produce. 99 is the potable water which will go to community, and this 5% of this potable water will go back for backwashing. So this much we need to generate. That is nothing but 99 into 1.05. Okay. So this is the Q. This is the value of Q. Though you take 99, nothing much difference will come. It is hardly 1 or 2 liters only. So but conceptually we need to take this as a cube. Okay, so for getting the total surface area, so Q is 99 into 1.05. MLD means what? Million liter per day. That means into 10 to the power of 6 liter per day. Okay, by rate of filtration. So rate of filtration is given in meter per hour. So 6 meter per hour. Convert this 6 into liter. 6 into 10 to the power of 3. Okay, we cannot convert this into liter. So let us convert this into meter cube. So if you convert this into meter cube, then it will become 10 to the power of 3. And if you convert this into number of hours, then it will be get divided with 24. Okay, 24 into 6 is in meter per day now, meter per hour. 6 is meter per hour. Okay. Now, so if you solve this, we will get the meter square value. If you solve this, you will get the total surface area. So what is the total surface area? What is the total surface area needed? Total surface area 721.875. 721.875 meter square. This is the total surface area needed. 721.875 is the total surface area needed. Here we know each filter area. So each filter surface area is equal to, so length by width ratio they have given, and also the width value is given. So L is equal to 1.35 times of width. From here we can write that from here L is equal to 1.5 into W, that is equal to 1.5 into 5.2. Okay, so this is length and this is the width. So each filter surface area is 1.5 into 5.2 square. Okay, we will get the each filter's surface area as 7.02. We will get it as 36.504. 36.504 meter square. So this is each filter's surface area. Then the number of filters needed. Total surface area by each surface area, that is equal to 721.875 by 36.504. Then how much it will come? The number of filters n is equal to we will get it as it is not given here. We will get it as, let us calculate. The 721.875 divided by 36.504. So it is 19.77. Okay, 19.77. 19.77, that means you need to round off it as 20 plus 1 we will provide extra. So 20 plus 1, that is 21. So 21 number of filters we have to provide. 21 number of filters we have to provide here to take care of this quantity. Okay, 21 is the answer. So let us go to the next question, 2018 again. So this is set 1 question. Actually it is not set 2, it belongs to set 1, 2 marks. Okay, 2018 2 marks, set 1 is the question number 38. Question number 39 is 2018 2 marks, set 2. It is set 2. Okay, 2018 question number 39. Question number 39. At a small water treatment plant which has 4 filters, the rate of filtration and backwashing is 200 meter cube per day per meter square and 1000 meter cube per day per meter square respectively. Backwashing is done for 15 minutes per day. Backwashing is done for 15 minutes per day. The maturation which occurs initially as the filter is put back into the service after cleaning takes 30 minutes. It is proposed to recover the water being wasted during backwashing and maturation. The percentage increase in the filtered water produced. So let us extract the given data first. Given that the rate of filtration and rate of backwashing both are given. Rate of filtration is 200 meter cube per day per meter square, okay, and rate of backwashing it is 1000 meter cube per day per meter square, okay. Now backwashing we do for 15 minutes. Duration of backwashing, it is 15 minutes. Duration of backwashing is 15 minutes. The maturation which occurs initially as a filter is put back into service. So I told you already, so when you put back the filter into service, so up to the development of this dirty skin squamid chicken, we don't consider it as a filtered water. So for that it is taking 30 minutes, okay, time of maturation. So duration of maturation is 30 minutes. Okay. It is proposed to recover the water being wasted. It is proposed to recover the water being wasted during backwash and maturation. So the percentage increase in the filter water produced. So whatever be the water is going out as a waste during these two durations, that water is also needed. Okay, if we consider that water also as for filtration, then what should be the revised rate of filtration? What would be the revised rate of filtration? Okay, so here the area, so we will find it for unit area. Here the area of the filter was not given, so we will find per unit area how much water is being wasted, okay, or water is used for backwashing and water is used for maturation. So we will get that water and we will add that water, okay, we will add that water to the treatment plant again. So what is the water consumed for backwashing? Water consumed for backwashing is 200 meter cube for a day. Okay, for a day for 1 meter square surface area. Volume of backwashing is equal to 200 meter cube per day per meter square into 1 day into 1 meter square surface area. If we take, then it is 200 meter cube. Okay, then it is 200 meter cube. Okay, 200 meter cube. Now here it is okay for 15 minutes. We are not going to take for complete day because we are doing backwashing for 15 minutes only. We are doing backwashing for 15 minutes only. Let us convert this into minutes first. 24 into 60 minutes, okay, into 15 minutes. This is the duration. So for a day means in a day we are doing backwashing for only 15 minutes. So that is why we have to take 15 minutes only, and we need to convert this quantity rate of flow into 15 minutes, and also we need to take the backwashing rate, that means 1000 not 200. So we need to take this as 1000 not 200. So this is 1000 meter cube per minute. So if I convert this into minute, 24 into 60 I need to divide. This is per meter square into 15 minutes we are doing the backwashing, and 1 meter square is the area I am assuming. Okay, so it is coming which is equal to, if you solve this, then you will get the value of volume of backwashing is 10.416 meter cube. 10.416 meter cube. This is the volume which is needed for backwashing. Okay, and also volume of water wasted. Volume of water wasted due to maturation. Let us take this as Vm. So that means maturation means when we are using water, when you are continuing the filtration process, in the filtration process up to the formation of Scumberg-Jaeger, we don't treat that the filter is matured. Okay, so that means here during maturation the rate of flow will be rate of filtration only. So rate of filtration only will be present here. For backwashing we need to consider the rate of backwash, and here maturation will happen during filtration, so we need to take the rate of filtration. So it is 200 meter cube. So per day I will convert it into minutes. That means I need to divide it here 24 into 60 per meter square. Okay, so here how many time? Duration of maturation is 30 minutes. So multiply it with 30 minutes and multiply it with the unit square area, surface area. Then you will get this as, if you solve this, you will get it as 4.167 meter cube. 4.167 meter cube. So total water, so VB, so total volume of water need to be filtered now. Okay, total volume of water, volume of wasted water is VB plus VM. So if you combinedly, it will be 10 plus 4.167, that is approximately 14.58 meter cube. 14.58 meter cube. So now this is the extra water we need to increase from the filter. This is the extra water we need to increase from the filter. So he is asking it in percentage. So percentage means what? What is the extra difference by initial into 100. So initial means what is the earlier filtering water volume? What is the earlier filtering water volume? So volume of filtering water, volume of filtered water initially, volume of filtered water initially is equal to rate of filtration into duration of filtration. Simply rate of filtration into duration of filtration, right? That is the volume of water into surface area. Everywhere I am taking unit surface area only. Here also I will take unit surface area. So rate of filtration is how much? 200 meter cube per, what I will do, I will convert this into minutes. Okay, 24 into 60 meter cube per day. That means 24 into 60 divided with meter square. So how many minutes actually it is working? It is working for a minute of, okay, it is working for a minute of, if you deduct 45 minutes, if if you deduct 45 minutes, if you deduct 45 minutes, that is the actual time of working. That is the actual time of working of the filter. Okay, so actually this is 200 meter cube per day if it is doing. Okay, this is 200 when it is working for a day. Okay, so that means first of all we need to convert this. So per day means, one second, small change we need to make here. Here, so rate of filtration is 200 meter cube per meter square per day, right? So for one day, that means for 24 hours, okay, that means for 24 hours, per 24 hours it is 200 meter cube per meter square, right? For 24 hours, what it indicates, 200 meter cube per meter square per day means for 24 hours it is getting this much of water. But now it is not working for 24 hours. It is working for less than 24 hours. That is, deduct 40 minutes. From 24 hours, if you deduct 40 minutes, like 24 hours means 23 hours 60 minutes, right? 23 hour 60 minute is nothing but 24 hour. In this 60 minute, 45 minute, it is wasting for backwashing and maturation. So exactly the filter is working for 23, 60 minus 45. 60 minus 45, that is how much? 15 minutes. Isn't it? 40, 50, 60, yeah. 23 hours, 15 minutes filter is working. 23 hours, 15 minutes, 30 plus 45, 550 plus 10, 60. 23 hours, 15 minutes filter is working. So here, if for 24 hours, this is the volume of water. If you multiply it with 1 meter square, so for 24 hours, if it is getting 200 meter cube, okay, 200 meter cube, then for 23 hours, okay, for getting, if you need 24 hours, you are doing 200. If you wanted to do this, if you wanted to do this in 23 hours only, then the rate of flow will be more. The rate of flow will be more. Are you getting me what I am saying? Are you getting me what I am saying? So you need to bring this much of water, 200 meter cube per meter square. Okay, so if you are taking 24 hours for doing this, if I reduce the time, are you getting my point? So if I reduce the time, then the rate of flow should be increased. So that means, so 24 into 200 should be equal to 23 hours 15 minutes into some x. This is the rate of flow needed. So if it is completely working for one day, then 200 is okay. But if it is not working for one day, it is working little less. If it is working little less, then the load should be increased. Simple. If you want to complete 10 number of questions in 10 hours, you can do it 1 question per hour. If you want to complete the 10 number of questions in 8 hours, then you need to do 1.2 question per hour, like that approximately. So that means, so if you are having one day, this is the rate of flow. But if you are having 23 hours 15 minutes only, then you need to have more rate of flow. We need to have more rate of flow. So that x I need to find here. That x I need to find here. That rate of flow. So that rate of flow is equal to 200 meter cube. So here I will convert this into minutes. Then it is 24 hour into 60 minutes by, okay, it is again minutes, 23 hour into 60 plus 15. This is the total number of minutes. So if you divide this, you will get the modified rate of flow as 206.45. Okay, we will get it as 206.45 meter cube for this duration. Okay, so this is the initial. Okay, this is the initial, because duration of filtration is little less, 23 hours 15 minutes only, and the rate of filtration was given for 24 hours. I need to convert this rate of filtration for 23 hours 15 minutes, and then I need to multiply it with 23 hours 15 minutes. Then I will get the rate of flow as 206.45 meter cube. This is the rate of flow, and that is the volume of wasted water. So the ratio, it is nothing but 14.58 by 206.45 into 100. So this is the answer, 7.06%. 7.06%. Okay, 7.06%. So I will conclude this session here. We will discuss the rest of the questions in the next session. Okay, thank you so much.